All right, so let's take a look at how we did overall on this. So for the seniors, their final exam, that test that I made everybody take last class, it actually is not going to count in the grade book for juniors and sophomores.
Yes.
Your average grade, ready for this? Average grade was 58.5. So you can look at what you made compared to the average. The average was 58.5. The first time around, we took the benchmark, the average grade was a 40. So our grades, we went from a 40 to a 58.5. I'm hoping to make another 18. So I got to see y'all twice in that time to raise it from a 40 to 58.5. Now we have a few more days left to go. So I'm hopeful that we can keep making another 18-point swing. So with that, I'm going to start on this one. This one's kind of like number 5. So if you have white space near number 5, that's where I'd encourage you to write this down. It says this: Julia kicks a soccer ball at 52 feet per second on an angle of 21 degrees. What is the horizontal distance the ball travels before hitting the ground? Round to the nearest second. All right, types of problems. Is this a triangle problem?
No.
Conic section problem. It's ellipse, hyperbola, something like that? No. Parametric. Does it involve a T? Actually, it does. It doesn't show it to you, but there is a time value in there. Where's the time value? 52. 52 feet per second. Yep. You will have possibly 2 of these on the test that are a real world application of parametrics. So there are 2 different ways I recommend solving these. The first one is to get the exact answer, very easy, where you use the formula chart. Not very easy, I'm sorry, very specific is what I meant to say. So I want you to go to your formula chart. Go to your formula chart. And on this formula chart, find where it says projectile motion. That's not the right side. I'm on the wrong side. You see the projectile motion? We have 2 sets of formulas. Now, because I don't want to be going back and forth and using the calculator, I'm just going to write them both down. We're going to be using the vertical position formula as well as the horizontal distance. Now, I'm going to write down the x equation first, just because we always use in the calculator, a lot of times we use the x equation first. So I'm going to write that equation first, followed by the y. So the equation was x equals, now you tell me after that. What does it say after x equals? Very good. X equals t v0 cosine theta. Now I want you to leave some space and then put the y equation. Y, put some space so we can fill in numbers in between for substitution. What was the y equation? So if cosine's x, sine is y, that's why we use a sine there. Okay, and this is where they get different. 1/2 GT squared plus H0. Okay, there's our formulas. Let's go through the problem. It says Julia kicks a soccer ball at 52 feet per second. That's our first value. Where will 52 feet per second go into the equation? That is our V0. That's our initial velocity. So in both of these equations, they're going to get a 52 right there. It says Julia kicks a soccer ball at 52 feet per second on an angle of 21 degrees. Where do I put the 21? The thetas. Right here, that's going to be our 21 degrees. Sorry, it's ugly. Okay. What is the horizontal distance the ball travels before hitting the ground? What does that mean we're looking for? It says horizontal distance. Yeah, that's asking you, what is the x value? So that's what we're going to try to solve for is x travels before hitting the ground, round to the nearest 10th. There's one piece of information that I forgot to give you that's very important. It's the initial height. So what would you assume in soccer? What do you think the initial height of the ball is going to be? 0. We're going to put a 0 there. It's not on this problem. I forgot to include it. So I'm going to say Julia kicks the soccer ball right here. I'm going to say from the ground. Now I can officially say that the initial height is 0. There's one more value you need to plug in is G. On this problem, what is our units? Are we in feet or meters?
Feet.
Feet. Why that matters? is because our formula chart has two different values for gravity. It has 32 as well as 9.8. And it all comes down to the unit. What unit are we in? B. So what's our value that we're going to take? 32. That's going to be 32 here. Okay, so to insolve, I need to find the x. Because I'm looking for x, I'm actually going to have to insolve the y equation first. So the value y is the final height of the ball. If h0 is the initial height, y is the final height of the ball. What is the final height of the ball? 0. Now, how'd you know it was 0? Because you kick a soccer ball, it goes off, and then comes back until it hits the ground, which again is a y value of 0. So we're actually going to put a 0 in there as well. That's what we're going to insolve. So open up your calculator, and we're going to insolve the y equation to get the time value, and then we'll substitute that into the x equation. So go to a calculator. No, not graph, sorry. New document, hit add a calculator, and now we're going to insolve the y equation. So how do I get to insolve? Menu 3.1, I'm going to just be in radians. Instead of y, I'm going to say 0 equals t. Now, if I just do t52, it looks weird. Calculator doesn't know how to do a variable followed by a number. So what do I do to make it not look weird? Multiply. T times 52, or parentheses would work as well. T times 52, not cosine, sorry, we're doing the y equation. I need to choose sine 21 degrees. Degree symbol, where do you find that? Pi button. There you go, 21 degrees. Minus 1/2. And then the gravity is 32 because we are in feet. T squared. Plus 0. Now, if I hit enter right now, it's going to give me an error. What'd I forget? Okay, and now I got to show you a trick that you might not have seen before. It says the answer is 0. Because what the calculator just found is this. It found this location right there. Time 0, the ball's on the ground. And that's what we told it to solve for. We said solve for when the ball is on the ground, right there. That's what that 0 was. Solve for when the ball's on the ground. It said, yeah, it's on the ground when t equals 0. Now, is that the answer we're looking for? We want to find, what is that t? So let me show you how to do that in the calculator. On the calculator, you can limit its answers or restrict the answers. So copy what we just typed in if you press enter. And this time, after the comma t, put comma, and this is going to be the lower bound, meaning the smallest answer you're willing to accept. I want any answer bigger than 0, so I'm just going to do 0.1. So I'm saying the smallest answer I'm going to be willing to accept is 0.1. And now when I press 0, it'll give me the time value when the ball actually hits the ground. What do you get this time? 3, 2, 1. 1.16. All right, I'm going to put 1.16 there. And what we're going to do now, if you remember, actually, you tell me, do you remember what we're going to do? We're going to save it as a variable, and then we will substitute it into the other equation. So to store it, hit control variable. Control variable does this store, the stow right there, and hit the letter T. We're going to save this as a letter T, so we don't have a rounding error. Now we'll take this and substitute it into the x equation. Hey, Matthew, you don't need that. You can shut your screen. All right, so I'm going to substitute it into the x equation. I'm not insolving this. You don't have to insolve it. I'm looking for x. X is isolated. I can just type in the right side of the equation. So I'm just going to type in t times 52 cosine. Notice the t is bold. That means something's saved there. Times 21 degrees. When you press enter, you should have your solution there. T times 52 cosine 21. What do you get when you press enter? 36.5? Is that what I'm hearing? 56. 56.5? 56.5? Great, that would be the answer. It does it say round to the nearest tenth? Yes. So the answer here would be 56.5 feet. That distance that the ball travels when it hits the ground, it's 56.50. That would be the X and Y at that location right there. That would be the location 56.5, and so that's how far the ball travels, 56.5 feet. Now, I am going to show you a second technique. Pretty much every problem we do today, I'm going to show you at least 2 ways of doing it. The reason I'm going to show you a second technique is because all the other problems with the T, you can solve really quickly using graph. Now, this is not as exact of an answer, but you can do it using graphing as well. So now, please press home screen and new document. Clear out what you have. Home screen, new document. Choose graph. Now, anything that deals with time is called parametric. Time is a parameter, so go menu, graph entry, and choose parametric. Now this time, what we're going to do differently is I'm not going to insolve anything. I'm just going to type in our 2 equations with their substituted values. So we're going to pretend like we don't know T. So T times 52 cosine of 21 degrees. There's your X equation. Your Y equation starts nearly the same, except we're dealing with sine because it's Y, sine is Y, minus 1/2. A lot of people here get errors in the calculator because they accidentally pressed the negative. Make sure you did minus, not negative. Minus 1/2, 32 t squared plus 0. Now, normally I tell you if they don't give you a time value, do either -5 to +5, -10 to +10. This is real world. I don't need any negative time. So I'm just going to leave it at 0 to 6.28. Just for the sake of time, we're just going to leave it where it is. Press enter. It should show you the trajectory of the soccer ball. Now, how you can do it is do it like we would do those other parametric problems where you trace the graph to see which way the ball's moving, where it is in time. So press menu, trace, and choose graph trace. How many people am I moving too fast? Am I moving too fast? Or are you with me? Not getting anything. Raise your hand if you're with me. Raise your hand if you're behind. It's like we're all good. Okay, graph trace. This shows you where the ball is with time, and down at the bottom of your screen, so if you look at the bottom right, it'll show you the values. I'm just going to hit the right arrow. Just keep hitting the right arrow. It'll show you the movement of the ball as it follows its path. And you're looking for how far does the ball travel? Well, this is not an exact answer, but notice it's telling the answer somewhere between 53.4 and 58.3. Now, what did we say our answer was? 56.5? But you see how our answer is right in the middle of there? Now, if there were multiple choice answers that are closer than this, what you can do, one last thing you can do, on multiple choice, you probably get the answer from there, just estimation. Notice in between those 2 numbers. But one thing you can do is if you go back to trace, and you trace, if you go to trace step, you can make it count by smaller numbers. It automatically counts every 1/10 of a second, 0.1. I'm going to change it to 100, 0.01. And now it'll count by smaller amounts of time. And you can get the answer. See, this is saying now I know it's between 56.3 and 56.8. So you can see how we're getting closer. You can just keep changing your T step if you want to count by something smaller and smaller to get an exact answer. I can change it one more time. I go to analyze, trace step, and I can change it to thousands. And you can really start closing in on when it exactly hits the ground. Here, you can tell it's right between 56.5 and 6.6. So you can just keep getting closer and closer. So you can do that all day, trying to close in. If you want the exact answer, do insolve. If you're looking at your multiple choice answers and they're way far away, you can just graph it and trace to figure out which one it is. Cool with that? Questions before I move on?